Now, what I will say the same thing that I say every single time we meet everyone, and that is the fact that we are from the Australian National University, the Centre for the Public Awareness of Science, and as part of the work we do, we want to and we intend to conduct research, because that's a great way for us to look at what we're doing and how we're doing it and how other people in the world are doing it, and then attempt to improve and get better and refine our approaches. As part of that, what it means is that we are going to be recording this session. Now, as always, once again, I am going to share in the chat now the links to our ethics documentation. Now, I encourage you, if you feel that way inclined, to read this, have a look, have a think, and if you would like to not be filmed, then please feel free to let us know. It is not a worry at all. Now, the other thing that I am going to share, as I always do, are a range of other links. Now, the vast majority of the people that I am seeing here are faces and names that I have seen before, so I'm sure you're all already across this, but I am going to share the link to our Facebook page, the link to our closed Facebook group, which is just for people like yourselves, people that we have worked with in the past. It's where we bring the opportunities to first. It's where we bring fun new things we're trying, and it's where we love to go to share ideas. So I really encourage you to be part of that. I'm also sharing our YouTube channel, which is a great place to go if you want to catch up on any of these workshops, because they're all recorded. And once they're recorded, I put them on YouTube, I send you a link, and if you are not at this recording in person, you can watch the recorded version, you can complete the survey, you can get your certificate just as if you were here in person, except without the added benefits of the fun interaction and the banter that goes on before and after the recording. All right, everyone. Now, I think that is the vast majority of the housekeeping that I needed to get through. I am going to very briefly share my screen because we are here this evening, this morning, tonight, this afternoon, in whatever time zone you are in. We are here because this is our very last workshop as part of the Hands-On Online Science Asia Pacific Workshop Series. It's been an absolute pleasure. We have engaged a range of teachers, educators, passionate communicators from across the Asia Pacific region in a whole range of different, interesting, engaging, and curious topics, from mathematics to tinkering to various different inquiry pedagogies. And today, we're going to focus on communicating and collaborating on climate change. Now, in a moment, I'm going to throw over to Graham. You may know him as Dr. Walker, depending on how I sometimes refer to him. He's not that scary. It's just a title. It's the amazing Graham Walker, and I will throw to him in one moment. But before I do, I wanted to share a video with those of you that are joining us in person today. Now, this is an early edit of a video that we are putting together to show a little bit of the journey that we have all been on as part of the Hands-On Online Science Asia Pacific Workshop Series. It's a mouthful, isn't it? We should have got a more streamlined name. But the first thing I'm going to do is stop sharing that screen, come back to this screen, and I'm just going to show you a video that articulates a little bit of a story of the journey we've been on before we jump into what's next. Now, one day I will figure out how to avoid those very awkward pauses whilst you click all the buttons and try and find out how to share your screen. I'm getting better at it, but I'm just not quite there yet. I'm going to optimize for video clip. I'm going to share the right screen to make sure you get to see what I'm looking at. There it is. I'm going to click this button and let's watch a short video. Graham, can you see that screen all right? Yes, let's do it. Thank you to everyone from wherever you may be in the world joining us. My name is Joe Duggan, and also with
all say hello.
This one holds a bit more pressure. I love people who say that they don't like mathematics.
Students noticed that these buildings have columns around the place. And so we did a control inquiry together.
I think only the upper levels, like high school, you get.
Do you have any advice on watch content?
Oh, I got 1, 2. There we go. 2 thumbs up.
For part 1, please tell us how you might implement a demonstration. I think it's crucial that you include some pictures or videos, and please keep in mind that.
And I'm going to stop that share now. Now, there's a few reasons I wanted to show that. One was, as I say, to show the journey that we've all been on. The other thing I wanted to show was that, remember our South African colleague, Steve Sherman, the one that spoke to us about maths? I had a meeting with him the other day on Zoom, and he still had that funny jacket and fake beard on. So it's just a look that he likes, not something that was special for us. The other thing that the other reason that I was showing that workshop was because at the end there we mentioned the competition that we are running as part of Science Circus Pacific. Now, it is this competition right here. This competition right here. Now, it's still open for a few weeks. It's been fantastic to see that we have had some entries coming in. And we'd love to get more. All we want is for you to submit a lesson plan on a new demonstration you've learned through the UNESCO Teacher Workshop Series, or something that's been inspired by the workshop series. And then we want to see you implementing that lesson plan. Tell us how it went, because the more we can learn from you, the more we can share with everyone, and collectively, the better we can do in this space. All right. Folks, I'm going to stop that screen share. I'm going to come back to everyone now. And I better, before I kick it off, I'd very much like to acknowledge that today I'm joining you from Ngunnawal land, and they're the traditional owners of the land that I am joining you from. I'd like to pay respects to their elders past and present, and acknowledge that that's where I'm joining us from, and also acknowledge the Indigenous peoples of any of the lands that you are joining us from as well. Before we go any further, I am going to introduce Graham Walker. Well, you know what? I'm going to let Graham introduce himself, because otherwise I'll be too formal. Graham, can you tell everyone who that wasn't at our very first session, maybe, a little bit about the amazing work you do all over the world?
Lovely. Thank you for that generous introduction, Joe, and welcome to everyone from wherever you are. And I'd also like to acknowledge the Ngunnawal people, whose lands that I'm sharing from, and wherever you are as well. Acknowledge the Indigenous peoples there. So my name's Dr. Graham Walker. I work at the Centre for the Public Awareness of Science at the Australian National University, and I get to work with Joe, doing all kinds of things. And one of my passions is kind of hands-on approaches to science education, especially where we can use common items to make these kinds of things really accessible. And since COVID has done its thing, we've been doing a lot more hands-on instruction using video conferences. And often people look at this platform and they think, well, how are we going to do practicals? How can we do online learning that is still hands-on, which is where science learning really thrives? So we're hoping to demonstrate that we can do kind of practical science learning in online formats. I'm also hoping to share some things about climate change, which is something that I'm really passionate about, Joe's really passionate about. And because you're here, we're guessing you're at least interested. And climate change is also global phenomena, but with a very local story. So I'm hoping today that we can share, that I can learn a little bit about what climate change and what some of the demonstrations we're talking about today means to you, and vice versa. So as we said before, or if you've just joined, please feel free to use the chat, raise your hand, interrupt, however you would like to interact is just fine with me. So Joe, are you thinking we should get into these activities and things?
I think the time is perfect, Grant. I think you kick it off. We'll probably get a few more people come in over the course. I have heard from some of our Samoan colleagues that unfortunately they've been held up with some other things, but they promised that they will jump on and watch the recording. But as we go on, I would imagine we'll get a few other people joining us.
Lovely. Awesome. And welcome to Chanel from Fiji, who's just joined us. Now, all right, so we're going to get into looking at some climate change education and hands-on approaches. But before I get into that, I wanted to just show you where I am. And the kind of setup I'm using, and I think we've all had to improvise. I know that a lot of you have been through lockdowns or are currently in lockdowns, and my thoughts go out to everyone who's still dealing with this awful pandemic. And my thoughts are with you for the way you're pressing on with education. And it's a real credit to teachers everywhere that they've been thrown this massive curveball, and the vast majority of teachers have managed to improvise, work online, and really carry on. And it's such a valuable thing for young people to have that connection to education through these really difficult times. And yeah, my thoughts are with everyone in that position. And if me and Joe can help with that, let me know. One of the things we've been trying to do to help, as I said before, is show these online approaches to science that can be done online. And I'm going to show you the way I'm doing it. I'm just grabbing my webcam. This could be a little bit disorienting, but you can see there's my messy office and all the bits of my office I don't want you to see. But this is the bit I do want you to see. Okay, I've got my laptop up on this old cupboard. So that gets it up to a nice height for me to talk to you. And the kind of framing and things when we're teaching online, it's really important. If I'm kind of all the way back here, or if I'm right up here, it's really going to affect how your students are learning. The other thing I've done is set up another camera where I can show my hands-on stuff. And you see we've raided the cupboard. I've got the good old, I think it's a 1970s retort stand, which I found is perfect for my webcam. And then I've got a spot down here where I'm actually going to do the hands-on stuff today. So if you are teaching science online at the moment, and yeah, it is easy to kind of knock up a setup like this. And we'd be happy to take any questions or any advice on that. And there's lots of different ways you can do it. With our students under lockdown last year, they're piling up books and things to improvise using lots of gaffer tape. So whatever works is great. I've got my second camera there, and just swap cameras on Zoom. I'll just adjust that. Whoa, you don't need to see that bit. And here, my trusty retort stand has just given up. Lovely. Okay, here we can see the area I'm going to work in when I do my hands-on stuff. Okay, so I've got two cameras, so you've got a bit of a better view there. Lovely. All right. So we're going to get into it. Now, as I said before, I'd love this to be an interactive session. So please feel free to jump in the chat, ask questions, whatever kind of suits you to interact. I'd love to hear your thoughts. Now, this is going to be broken into two parts. I'm going to share briefly just some ideas from the research literature about what makes engaging climate change education. And then we're going to get into some hands-on stuff. So you probably saw I've got a whole lot of things all around my table here, and we're going to actually go through a bit of a story of climate change. But I'm going to give you a bit of background as to some of the approaches and what some of the research literature says first, because some really, really important things when we think about climate education. It does have a lot in common with other areas of science education, but it's also got some really important considerations. Zoom is arguing with me. There we go. We want to share our screen. Lovely. Great. Yeah, so I'm going to talk about hands-on approaches to climate change. First, just to say, as Joe said in the introduction, we're in Canberra, in Australia, and climate change is a global problem, and we have to respond to it globally. That's one of the challenges, but it has a real, I guess, a real local impact. And I guess I can kind of see what's changing in Australia. I can see more extreme bushfires. I can see coastal erosion. I can see my tomato growing season changing. So there's lots of things that I see as the impacts of climate change. But I wanted to start off by saying that I don't see what you see. And I know that climate change means different things in different parts of the world. And I just wanted to acknowledge that first off. My passionate belief is that climate change is only going to be something that we're going to fix as a species, as a planet, when we can kind of all come together. And that's why I'm really passionate about sharing approaches to climate change, how to communicate it, how to do effective education. But I don't claim to know what it looks like through your eyes. So I'm hoping through the interactivity and however you want to share, that I can see climate change a bit more from your perspective, and through the course of the session you'll see it a bit more from my perspective. What I really believe is we need more shared perspectives, okay? If all our politicians met at COP26 in a few months and they all had the same perspective, we'd have a lot less of a problem on our hands, but we don't have that shared perspective, and my opinion is we don't have enough empathy about what climate change means to other people. So I hope I can see it more through your eyes. The other thing I should point out right from the get-go is that the research I'm going to present today comes from a kind of global context, and it's largely Western oriented, okay? And that's a problem, okay? If we're going to tackle climate as a whole planet, and that's how it has to work, it's that kind of problem, then we need much broader voices, okay? So I'm going to present things that kind of present things in a largely, it's global research, it's come from all around the world, but it's largely Western, and I'm hoping that I can see what climate education and some of the challenges and also successes you're having locally throughout the session. Now, if you're interested in digging into what the research says a little bit more, the two papers I'm going to focus on in this very brief bit, and I promise this will be the only lots of text, lots of PowerPoint, lots of academic stuff, are these two review papers that were done recently. And they've really looked at a number of different climate change education papers, approaches, and tried to find out, well, what makes it tick. The other one I've referenced there, if you're doing things in informal environments, or you're working a lot outside the classroom and you say communicating climate change with communities and things like that, really recommend that third article by Suzanne Moser. If you have trouble getting any of those papers, you can get in touch with me or Joe, and we'll be happy to share a copy with you. So I'm going to present the findings of these first two papers, which really sum up some pretty important things about climate education. The first thing they say is that, like all science education, it needs to be relevant to people. And as I was saying in the intro, climate is a different thing wherever you are. And some people are a better place to deal with it. Some people are worse placed to deal with it. And a lot of the people who are dealing with the worst impacts of climate change are also the least prepared to deal with them. So making climate change personal and making it relevant is important. So putting it in a local context, using local examples, can really help students to take what is a really kind of abstract idea. A lot of these things happening on a global scale, you kind of that can be hard to get your head around. So having concrete local examples is really important. One of the really important things that those examples and those local links do is they put the science in a human context, okay? We live with the implications of Newton's laws all the time, but they don't have a huge kind of human effect. Climate change is very difficult. It's a very difficult problem, and it has a huge social dimension and a huge human dimension. And we need to acknowledge that when we're teaching it. Okay, you might be teaching it within the science curriculum, but it probably links into other curriculums as well. And my personal view is it's always good if the science curriculum is thinking about the social sciences, thinking about the humanities, particularly when it comes to very human problems like climate change. The other thing that making the learning personally meaningful, making it relevant, is that it acknowledges that there's emotion in this. Okay, I've got a 4-year-old son, and it distresses me, the world he's going to grow up into. Part of the reason that I'm passionate about sharing educational approaches and trying to change behaviour. But climate change is an emotional thing. I get emotional about it. You might get emotional about it. That's a pretty human thing. It's pretty devastating. And when we teach it, we need to take that on board. And towards the end of this bit, I'll share some just really fundamental stuff to consider when we are teaching what can be an emotional, it is a distressing topic, and we need to think about that when we're teaching. All right. Now, the second thing that these papers came out with is that effective climate education works best with active learning, okay? So what I'm doing now, I'm blasting a PowerPoint at you. Not the best approach, but don't worry, we will do lots of hands-on stuff in just a second. So active learning, like hands-on and inquiry-based formats, which is what I'll share with you today. They also really recommended things that bring in that human dimension. So getting your students involved in debates and discussions, having them reflect on what the science means for people. You'll find a lot of resources out there for role-playing and try to actually putting students in the headspace of some of these very difficult decisions that people have to make about how we must act on climate change. Going out, doing field trips. Now I'll pick up on this in a second as well. And something that you're the experts on, because you certainly don't want to hear me sing over this Zoom call, are more culturally responsive methods to engaging with climate change. So you'll see some wonderful stuff around poetry. In fact, some wonderful stuff from the Federated States and Micronesia, if I'm not mistaken, Joe. Yep.
Marshall Islands.
Oh, the Marshall Islands. Sorry.
Islands.
Yeah, I knew it was nearby. But yeah, some wonderful stuff using poetry, dance, stories, drama, puppet shows, all kinds of stuff. And these can be great ways to explore things with your students, where you can kind of bring in these personal, locally relevant approaches to try and make sense of this science. And finally, just getting students working in groups and in kind of social interaction, because really, a lot of the science of climate change is it's decided. A lot of the things we do are also really clear. The bit of the puzzle, in my opinion, we're having trouble with is getting all the people to play together. So modeling those kind of things for our students and the kind of social dimensions to this science is really important. Now, all of these active learning approaches, they're empowering for students. Put students at the middle of what's happening. Let students explore things on their own terms, or at least somewhat on their own terms. And it is really important when we're dealing with climate that we don't leave our students feeling like they can't do anything and like they're powerless, which, to be honest, is an easy way to feel dealing with a problem like climate change. But there are lots of things that we can do to empower students, and active learning is one of them. Finally, these papers had some great suggestions for how to extend students and connect better with climate change at a local level. They talked a lot about these kind of deliberative discussions. So this is, I guess, a bit of an extension of these kind of scenarios and role playing. One that I would really endorse and encourage you to try out is interactions with local climate scientists and the research happening locally. So this can tick off this box of seeing the local impacts of climate change, but it can be also really powerful showing students that there's people in your country working on these problems, trying to solve things for the community. So it's great for role modeling, great to show the careers, but also great to show that, you know, this is science that's happening locally. And another big thing that these review papers highlighted is around misconceptions. So the ozone hole is a great example. It's another bit of damage we've done to the environment, but how it interacts with climate change is often something that students and people more broadly might not be that clear on. So actually eliciting misconceptions from your students and taking that constructive approach, constructivist approach is one thing that they found really powerful. Finally, and this is another one that I kind of ding, 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 I think this is a great idea, is actually getting your school involved or your school and your community involved in local projects. So we're working with a university in Fiji, the University of Fiji, in fact, on a project to promote recycling at the school and looking at that as something that the school can do to take action and empower students and make a difference as well. And I just encourage you, if you're in the chat or on the chat, I would love to hear any examples of how you're approaching climate change teaching, maybe using some of these ideas, maybe using others. And I'd really love to see any comments in the chat about the way you're approaching it. If you want to pop in what worked, what didn't work. Yeah, just how you approach that climate. We might come back and have a chat about that. So feel free. If you're not doing anything, but you'd like to, maybe just pop that up, okay? All right, lovely. Finally, just some key points, kind of picking up on that emotional dimension that I mentioned earlier. So climate change can be daunting, especially for young people. You only have to turn on the news or, you know, jump online to see that there's a lot of things happening, a lot of impacts, and it can be daunting, especially if you're a young person. So one of the things that the research shows about this is that so it's not so daunting and so people feel empowered while they're learning about climate change is to balance talking about the impacts and kind of what's going wrong, okay, with the solutions, okay? So talking about renewable energy, talking about things that people can do at a local level. So this isn't about glossing over the urgent need to deal with the climate crisis, but it is about presenting a balance of here's the stuff going wrong and here's the stuff that you can do to address it. So it gives an empowering message, okay? So when we're teaching climate, it's really important to have that balance, and this could be things like, you know, what communities are doing locally to address the problem, and this can really empower students. And this could be scientific solutions. They could also be civic solutions, like lobbying your parliamentarians, like engaging at a global level. Okay, just. Oh, okay, so we've got some people. Thank you for people sharing. Yeah, so people doing field trips, coastal cleanup. So it's a great example of where you're looking at the local situation, but you're also taking action. Thank you for sharing, Louis. And yeah, lots of other things around renewable energy, stuff that people can apply. And thank you, Patty. Hands-on approaches, video clips, and yeah, so that's very much what we're going to do. Thank you for sharing. Okay, on Earth Hour, okay, great to be able to tie in with these kind of global events, and COP26 coming up. There will be no doubt a lot of educational things happening around that. Thank you, everyone, for sharing there. But one of the things coming out of this is that it's really important that we have a balance of the stuff going wrong and the solutions. I'm going to try and do that today. And there's a lovely quote from Suzanne Moser about doing this in a communication context. All right, so enough PowerPoint, over to the fun bit. We are going to look at a whole lot of demonstrations and hands-on activities that have something to do with climate change, both the root causes and what's happening, the actual science, through to the impacts. And of course, really importantly, I'm going to finish talking about lots of the solutions, trying to present that balanced narrative. And Joe's just unshared my screen. I'm like, what am I talking about? What I was going to talk about, and I just
sorry, Graham. I was trying to make you the feature of what was happening. I'll give you the reins back. I didn't mean to drag the
That's all right. No, that's all right, Joe. That's lovely. So what I wanted to say just before I go away from the PowerPoint and we get all hands on is that I'm going to present stuff that is the actual phenomena, okay? So the things that are a fairly good model for what's really happening with regards to climate change. I'm also going to present a lot of models, okay? And we're going to use analogies. Now, just a word of caution, if you're using this models and analogies with your students, be really careful that students have a clear idea of what the model means. Okay, in some of the research I've done, not around climate, but in health communication, students will sometimes take away part of the model and part of reality and mix them together. Okay, so whenever we're using models or analogies, it's really, really critical that you kind of debrief with your students and you work with them as you go along to make sure they understand that this model represents something in the real world and they can make really clear links, okay? Because otherwise we can really reinforce misconceptions, and I'll pick up some examples of that as well. The other thing I should say is that some of the activities I'm going to show you today do have safety issues. So if you need to do additional risk assessments to use these in your schools, please do. If you have any questions about safety, if you're not sure about anything, just drop us a line, okay? Because we're all for making science education exciting, and sometimes that does involve managing risk, but the last thing we want is anyone to get hurt. So any issues with safety, please drop us a line. Always happy to talk about things like that, and think about the age of the students you're working with, both from a safety point of view, but when we're thinking about models and analogies, you'll find that young students in particular, they just haven't developed enough to hold the idea of what the analogy represents and what it means in the real world. So with younger students, be extra careful with that. Okay, wonderful. And thanks for those extra comments on the chat. Oh, and lovely to see we've got some government people. Wonderful. Yeah, reduce, okay, and talking about waste management, okay. A big thing that we can do with climate is just use our resources better, and this can have great effects at the local level as well. All right, now I will stop sharing, and we're going to get into some hands-on stuff. Now, the first thing I'd like to share with you is a couple of models to actually talk about what's happening. And I might, rather than me just showing you, I might just ask in the chat, can anyone tell me, like, what's driving climate change? Like, what's creating the effects we're seeing? Any suggestions at all? I know there's lots of answers to this, so just pick the one you like the most. I'd love to see any comments in the chat. What's actually causing climate change? And this might be different at your local level. I know certainly in Australia, it's how we're making our energy and the kinds of fuels that we're burning to create energy. So that's definitely a big issue for Australia, to get off the coal and get on to cleaner fuels and renewable fuels. But I'd love to hear about how you see it locally. What's creating climate change? Okay, so we've got people saying fuel, fossil fuels. Yeah, absolutely. And what is it about the fossil fuels that, yeah, deforestation, okay? This is another big one in my country, and thank you, our friends in the Philippines, for sharing that. So we are going to look at a little demonstration to look at what's fundamentally driving climate change, and all of the things that I've seen in the chat there, they all come back to these gases that we're putting into the atmosphere that are causing an enhanced greenhouse effect. And I'm going to do a really simple little demonstration and a simple model, sorry, that shows this idea. And I should also acknowledge the lovely people at CESM in Timor-Leste, who shared this demonstration back in the land where we could actually travel there. But it's a wonderful demo, a wonderful model you can use to talk about climate change and the enhanced greenhouse effect. Now, the first thing that I've got there that I've got here is just a piece of wood. Now, you could use anything, okay? Often when I'm running this activity in schools, or when CESM are running it in schools in Timor-Leste, they'll just find a wall. We just need something that a little ball can bounce off. And you could use any kind of little ball. I just found whatever was lying around my office, but you could use golf balls. You could even just use little pebbles, okay? Doesn't really matter, as long as they'll kind of bounce off something. They don't have to roll nicely. They need to bounce off. Because what these little balls are going to represent is our sunlight, okay? In particular, the infrared that is coming from the sun, which causes our planet to heat up. Now, this is actually a really good thing, okay? At the moment, we have gases like carbon dioxide in the air, okay? And they actually trap some of the heat that comes down. So what we've got here is a little model. I'll just take this one away from now. A little model of how the greenhouse effect works. So you could run this in different ways for your students. You could run it as just a simple activity. You could run it as an inquiry, which extends out over a lesson. But we're going to start by taking some of this radiation from the sun, and we're going to bounce it off the earth. Now, as you just saw in our model, some of it goes all the way back out again. And this barrier here, this is going to be space. So on this side, we have space. And on this side, we have the atmosphere. Lovely. Okay. So the sun's radiation comes in, hits the earth, and some of it bounces back to space, and some of it is actually trapped, as that one was, by gases in the atmosphere. So the structure of gases like carbon dioxide actually lets them trap heat in the atmosphere. So here we've got some heat that's been trapped, and other heat will return eventually back to space. Okay. Now the issue we're having, and we've had some great suggestions on the chat about what's causing these changes, and a reliance on fossil fuel. We've had other people mention agriculture. Thank you, Shannon. And the greenhouse gas we get from agriculture is methane, okay? And we might get the fossil fuels that we're burning contributing more carbon dioxide. Now, you can probably see what's going to happen. If we put more of these balls through, some of them might get back to space, but a lot more is going to be trapped the more of this gas that we have in the atmosphere. So our greenhouse gases are causing more heat to be trapped in the atmosphere and producing what we call the enhanced greenhouse effect. So look, you could use just about anything to set these up. This is just what I had lying around. And you could use any kind of balls or containers or bits of wood or stones and sticks, whatever works for you. What is important, just going back to what I was saying earlier, is that students understand the model, okay? You wouldn't want, say, students walking away thinking, oh, it's the takeaway container boxes. up in the atmosphere that are trapping the heat. We need to make sure that the model is clear in their minds and what it represents. So this is a really simple way just to show that advanced greenhouse effect. If you wanted to extend this into some kind of inquiry or a longer session, you know, you could try it with different number of balls. You could steadily add more gases. You could put all that into a table and you could graph it and do things like that. Okay, so can use it as a simple demonstration, but you can also use it as something. You can also use it as a more extended kind of inquiry. Okay. Are there any comments or questions about that? Did people see what the model represents, or any thoughts about how we could make sure that students are grasping the model? If there's any comments, or if anyone wants to turn off their mic, or sorry, turn on their mic and sing out, feel free.
The other thing, Graham, that I'd be curious about would be if there are any, you mentioned other materials or other ways of conducting this experiment. I'm curious about our colleagues from different areas. What's the first thing that comes to their mind for different materials that they could use to implement this particular demonstration?
No, that's a great thought, Joe. So yeah, we'd welcome any comments or notes in the chat. If you don't have little balls, what might you use? One of the lovely approaches that I've seen when we didn't have any props was to actually use people and kind of have people representing the different things. And actually scaling it up, maybe using soccer balls and things like that. It was really engaging for the students. But I'd love to hear how you might approach it and what materials you might use. Alrighty, lovely. So we're going to have a look at another model now, and this one is. It's going to model, again, the greenhouse effect, but we're actually going to look at the real phenomena, okay? We're actually going to get something to warm up and measure the temperature. So once again, we've got a model, which means we have to be careful that students are grasping what the model represents. But this one is a little more straightforward, I'll show you. So for this activity, you're just going to need a couple of glasses. Now, I've rifled through our kitchen and found two identical glasses because I want this to be a fair test. So with a lot of these activities, you know, we can use them for climate change education, but we can also talk about the nature of science and lots of other things with them. So I've chosen two identical glasses because I want this to be a fair test. The other thing that I've got is just a soft drink bottle, and I've cut the bottoms off these so that they'll stand up nicely. And in a second, we're going to take our two glasses, which could say represent the oceans, or they could represent the whole Earth, and we're going to put these greenhouses on them. Now, I want to ask you, what do you think these represent? Okay, I've got one that's got the lid off, and I've got one that's got the lid on. So have a think about how what effect these might have if we put these over and we put them out in the sun. What do you think these two bottles represent? Anyone want to have a stab at it in the chat or to sing out? Okay. Any guesses at all? Maybe think about which one is going to maybe trap the heat better. That's the tricky thing with Zoom. Hey, all right, excellent, thank you, Louis. So Louis said that these represent the atmosphere, and they do. That's exactly right, thank you. And they're going to trap heat differently, okay? If we had this out in the sun, you can imagine the sun's rays coming down here. They're both going to cause the air inside the bottle to warm up, so the atmosphere to warm up. And as the atmosphere warms up, it's going to warm up the water in the glass as well. Okay, think about if you run a cold bath in a hot room and leave it for a while, the water warms up. And the same thing's happening on a global scale. Now, this bottle is going to trap the heat even better. You can think of this one like the advanced greenhouse effect, and this one like the regular greenhouse effect. Okay, and yeah, thank you, Louis. You said the one with the lid is going to trap heat better. Okay, so once again, a really simple activity, but this is one that's got a bit more potential to be a student activity. Actually, they've both got good potential, but this one, if you've got a little thermometer, doesn't have to be a digital one, whatever that you've got, you could actually take some measurements and do it over time. So usually, say if you wanted to set this up for a lesson, you can maybe start at the start of the lesson, and then every 10 minutes, come back out, quickly take your bottles off, measure the temperature, and we can do things like graphing it and things like that. If you don't have access to a thermometer, use the one that nature gave you, and we can just put our finger in there and just see if we can get a kind of qualitative change. Okay. So once again, just using very, very simple items to show what's going on between the regular greenhouse effect and the enhanced greenhouse effect. So you can almost think about this bottle, the lid on the top is these additional gases, carbon dioxide and methane, that we're putting into the environment. Okay, and thank you for those comments on the chat. Lovely. Now, we've talked a little bit about what's actually happening and these greenhouse gases, and I know some people put some comments before, but I'd love to hear where you think the greenhouse emissions are coming from, either locally or on a global scale. Where do you think they're all coming from? And I know someone has already answered this question previously, saying, yeah, fossil fuel reliance. So that's certainly a big one. Any other places that these gases are coming from, please feel free to pop it in the chat. And it's different in different places. Yeah, okay. So thank you. Louis, you get the interactivity gold star. Yeah, and a really good point from Louis, saying that it's first world or developed countries. Okay, one of the things that I think is most unfair about climate change is that the countries that are being impacted the most are usually the ones that are least responsible. So it is not right. But you're absolutely right. So on that note, we're going to talk about one of the fossil fuels that we've been discussing a lot in Australia. And I know in different countries you might be making, you might be getting all your energy from hydro, which is great. You might be using generators. It could be all kinds of different things. And Chanel's just said natural gas drilling. And what I've got in here is actually some natural gas. Thank you for the little cue, Chanel. And natural gas does release a lot of methane. So you'll often hear people saying that if we move away from, if we can move away from fuels like coal and move on to fuels like natural gas, that will reduce emissions. And this is true. But if we look a bit deeper in that science, what the most recent science is saying that we need to transition away from fossil fuels urgently. We don't need transition fuels like natural gas is what the International Energy Agency is saying. We need to move straight to renewables. But the fuels that we do use to make electricity have really big impacts on how much the kind of emissions that we create. And even in the process of extracting natural gas from the atmosphere, we produce a lot of methane as well. So it's not as clean as some people might tell you. But we are going to look at this as a fossil fuel and to think about where is this carbon dioxide that we talked about before, where's it actually coming from? And I've built a little bit of equipment. Now, you can make one of these, okay? It's not very complicated. In fact, in the chat, I've put a link to to a clip where you can make one of these, but it's pretty straightforward. What I've done is I've taken the lid of a soft drink bottle and I've drilled out the lid, and then I've slipped this piece of tubing over the top of the lid and just use some tape to secure it. And Joe, would you mind copying and pasting that link just in case anyone who's joined us more recently can't see it? Yeah, so you can make one of these, and this is one of these demos where I should say that there are some safety risks. So please do your local risk assessments, and if you've got any questions, just get in touch. We can share some further resources. Now we're going to actually produce some carbon dioxide, okay, just a little bit, okay? And we're going to see where these emissions are coming from. Now, one of the tricky things with climate change, with gases like carbon dioxide and methane for that matter, is that these are odorless, colourless gases. So while a fossil fuel energy plant is spewing heaps of pollution out, we don't really see it, because these are invisible, odorless gases. And I think if carbon dioxide was kind of bright blue and you saw it floating around and the air was changing colour, we'd probably be taking a lot more notice, but it doesn't. And that's one of the issues. So this demonstration, we can actually kind of make some of these emissions, a very small amount, and try to make that a little bit more real. Now, there's some wonderful chemistry as well in this. I'm not going to stress the chemistry, but you can use this to teach all kinds of things. Today, we're looking at this demonstration in a climate context. Now, to make this a little bit more fun, what I've got here is a little marshmallow. Okay, it's getting late in the day here in Canberra, so I've got this just in case I need a little sugar hit. We're going to pop that into our cannon like that. Okay. The next thing I'm going to do is to measure some of my fossil fuel out. Now, if you are teaching chemistry, you can do some wonderful stuff to work out how much fuel you need and how much oxygen, which is already in the bottle, and actually unpack that chemical equation. I won't go into that today because we're more interested in looking at this in a climate context, but I've got about 40 mils of our fuel. I'm going to pop the fuel in here. I've drilled a little hole just in the bottom there. And we're actually going to see some carbon dioxide being made. All right. Now, you probably heard this and you probably saw it as well. You probably saw that flame, which is actually where our carbon dioxide is being made. So in here, we've got our hydrocarbons. Okay, most fossil fuels, lots of carbon, lots of hydrogen, and it's that carbon in there combining with the oxygen in the air that makes our carbon dioxide or our CO2. So we can use demonstrations like this to talk about where the emissions are coming from. Now, one of the other places that we see a lot of emissions is in transport. And while I'm not proud of a lot of things that my country is doing about climate change, I am proud about what my city is doing here in Canberra. We've gone fully renewable for our electricity. So everything's coming from wind and solar and hydro. Okay, so it's a great thing. What we haven't worked out is transport. So we're all still driving fossil fuel powered cars, or almost some EVs coming online, mostly fossil fuel powered cars, some hybrids, again, still making emissions. So transport is a big source of emissions, okay? I know everywhere in the world, we've got emissions from cars. For our friends in the Pacific, emissions from shipping and things like that are another big issue locally. But of course, these are all global problems, because wherever the emissions are made, they go into our shared atmosphere. Now, we can talk about emissions from transport, again, using really simple materials. And this is another one where you'll see in a minute that this one is one where we have to consider safety issues. And hopefully my director isn't going to walk in when I do this, because it's quite noisy. Now, I've got a coffee tin here and I've made sure that it's metal, and I've just put a little hole in there. Okay, you can just do that with some scissors. Now, the other thing I did is I worked out the volume. Okay, it's about 1.56 litres. And if you like your chemistry and you like your maths, you can work out that you'll need 49 mils of our fossil fuel butane to react with the amount of oxygen that's in there. So we can bring climate teaching into other courses, whether it's physics or chemistry. And I know in a lot of places, in almost all places, it is a formal part of the curriculum again. So we're going to see these emissions from transport. And what we've got here is a pretty good model of a car engine. Okay, it's a cylinder, just like in a car engine. I've got my fuel injection. I'm going to take this. I'm going to get my 49 mils, put the lid on. Just something to think about is if you have overhead lights in the place you're doing this demonstration like I do, as we get the energy out of this fossil fuel, we're going to create some carbon dioxide, but we're going to create a whole lot of energy, which is going to shoot the lid off. So just take care with where that lid's going to go. I'm going to pop my fuel in here. And once again, we're going to have a look at some of where these emissions are coming from. All right. Now, again, I can feel the heat produced, and the way the internal combustion engine, car engine works is that once we burn that fuel, we create a lot of hot gas. That hot gas is under pressure, and we can use that pressure to apply force. You saw the force that lifted our lid off, and this is the force that eventually drives the car's wheels. But in that gas that is providing the force is also our carbon dioxide, okay? So once again, we can show simple demonstrations or using simple materials where these emissions are coming from. Now, this activity is not one that I'd suggest you let your students do, but it can be a really nice thing for at the start of the lesson to get students engaged, to give them a bit of a stimulus, something to hook them in as you talk a little bit more about the theory and about what these emissions are actually doing. So you might see that in the course of this workshop, I'm trying to string a little story together. And that kind of narrative, how the ideas link together, is a really critical thing that I'm sure you're already thinking about in your lesson plans. Now, we've talked about a few different fuels. I've talked about coal and natural gas. If there's other fuels that are more relevant to where you are, I'd love to see any comments in the chat as well. Now, next we're going to have a look at what are these gases actually doing. So in my little story, I've talked about how the greenhouse effect, where the gases are coming from to drive the greenhouse effect. Now we're going to talk a little bit about what's actually happening. Now, one of the impacts we've seen in Australia is we've had a lot of droughts and we've had worse fires. I'd love to hear about any of the impacts that have happened in your area in the chat. I know we've got people from all across the Indo-Pacific. So if anyone's got any kinds of climate impacts, things you've maybe explored with students or things that you've seen in your day-to-day life, I'd love if anyone wants to share them in the chat. One of the things that I've thought a fair bit about is what's happening to coral reefs, and I know this is when I talk to friends in the Pacific, it's something they're worried about, and certainly with us in Australia as well, we're seeing our Great Barrier Reef, this majestic thing, just unbelievable, experiencing severe bleaching and things due to climate change in a large part. And thank you, Patty, for sharing some things that are happening. Now, I don't live next to the ocean, so I don't see these things day to day like a lot of you. So it's really good for me to see, well, you know, that climate change affects us all in different ways. And as I said before, it's that empathy that's what I think we need more at a global level if we're going to fix that. All right, wonderful. Someone's talking about saltwater intrusion. Yeah, lovely. Joe has got a lovely little video there. Soil erosion. Yeah, we're seeing from deforestation. but I might pick up on a suggestion from Patty, and thank you for everyone that shared there, about sea level rise. Okay, and once again, we can explore these ideas using really, really simple materials. Oh, only a few videos turned on. And what I've got down here is just a little candle. And if you've got a candle and some balloons at home or at school, then this is a very, very accessible activity. So what we're going to do is look at what's happening to our oceans and the water in our oceans. I'm going to start by blowing up a balloon. Lovely. And we're going to heat up this balloon. Now, I'm going to light my little candle. And as I was saying before, we can use these climate activities for teaching about climate, but we can look a lot at the nature of science and other things as well at the same time. So on that note, I'm going to ask you all to make a prediction about what's going to happen as I lower this balloon towards the candle flame. So what's your prediction? What's your hypothesis? Okay, I'm gonna wait till I see some hypothesizing in the chat before we do it. What's gonna happen as we lower this balloon down? Joe's not sure. What do other people think? Expand and burst, I guess, is Chanel. Lovely. Guesses are fine. That's all the professional scientists are doing in the lab as well, is making guesses, testing out. All right, some other people expand and pop. Okay, so looks like we're thinking about what happened in there when it got warmer. Wonderful. All right, that's some nice hypotheses. We're going to lower it down and find out what happens. Oh! Off it goes, okay? All right, and I've got some bits of balloon all over the place. So you're right, as soon as that heat from the flame touches our balloon, burns the balloon, and it pops, okay? Fairly predictable. Now, what I've got here is a second balloon, okay? And you'll notice that with my second balloon, I've only made one change, because I do want this to be a fair test, and I want to be able to talk to students about the scientific method as well as what we're looking at with climate. Now, it is hard to, actually, no, it's easy to see that this balloon has one variable that is slightly different. Okay, I've popped some water in it, okay, and to get the water in, you can just fill it up from the tap a little bit and then blow into it. If you're using tank water or you don't have water under pressure, another thing you can do is take a bottle of water, kind of put the balloon on the top and squeeze it in. Whatever you do, don't do what I just did in our kitchen, and that is to put the water in it and then let it spray all over your pants in a quite embarrassing pattern. And let's just say I'm happy that Zoom is only capturing me from up here. But you want to get a balloon that's got some water and some air in it. Now we're going to make another prediction, okay? And thank you for your lovely hypotheses before. What's going to happen this time as we lower it down? Okay, so if anyone's got some predictions in the chat. And don't worry if you're not sure. We'll expand and burst after a longer period of time, someone's saying. How much longer do you think? All right, so it'll expand and burst, it won't pop. All right, let's see. So I'm gonna lower it down. And you can't see it touching the flame just because of the camera angle. And that's something to think about with remote teaching, is how we can best position our cameras. But I can show you that it has been touching the flame. Now, someone has said that it'll pop after a longer period of time. So let's really give it some. Okay, it's fully in contact with the flame now. It has not popped, and you'll see that I've got quite a lot of soot on there, okay, enough to draw a little smiley face. And because the only variable we changed in this activity was the water, we know the water must be doing things, okay? Okay, now, this can be a lovely demonstration to talk to students about the heat capacity of water, if you're teaching chemistry, or the properties of water, but it's also a great analogy for what's happening in our oceans, okay? Most of the heat that's been trapped in the atmosphere by our gases like methane and things like that is actually being absorbed by the oceans. Water is really, really good at absorbing heat without getting too much hotter itself. It has a high specific heat, or it takes a lot of energy to heat it up by only a small amount. Now with climate change, this has been lucky for us because our atmosphere would be unbearably hot, or it'd be a lot hotter already if the oceans hadn't been absorbing heat. And most of the heat that the additional greenhouse gases we're putting into the atmosphere has actually been taken up by the water. Now, it's a very bad thing for our plants and animals that live in the ocean, okay? It's one of the things that drives coral bleaching and lots of other things, okay? It changes even how whales and dolphins communicate. Changes as those oceans absorb the heat and heat up themselves. So a nice little activity that we can show students that the water really does absorb heat, and it can absorb a lot of heat, and that's one of the global processes that is happening.
Graham, now might be a great opportunity. There's a couple of things that come to my mind when watching that particular demonstration. Now, I was going to show one of them, but I've decided I'm going to show the other after Paddy brought up saltwater intrusion. Now, that's one of the things that particularly further from the coast, and here in Canberra in particular, we don't see as an immediate threat from climate change. I grew up on an island that was further south, a place called Tasmania. But even down there, saltwater intrusion was something that we were aware of, but not something that was being an immediate threat to our livelihoods. Now, in a lot of smaller island nations, and from all the conversations we've been having with a bunch of our colleagues, particularly across the Pacific, we're learning that saltwater intrusion is a bigger stressor and a bigger pressure than we perceive here in Australia. And because of that, we've been thinking about, well, how can we create a simple demonstration, like the simple demonstrations that Graham's been showing, to articulate that challenge of saltwater intrusion? A colleague of ours has done some thinking, done some practicing, and has tried to pull this together into a neat, short video that will hopefully articulate this challenge quite well. Now, I'd love to show it to you all now, but I'd also love you to think about, as you watch this, what could you be doing in your hometown, your country? What could you be using instead of the materials that you see within this video that are going to make it more relevant, just like Graham said at the start, to your local context, and help it to connect with the people that you're communicating with? So I'm going to play this video now. Again, you think whilst I was talking I'd be able to wrap this up, but I haven't yet. All right, I'm going to share my screen now. And it's about 3 or 4 minutes, this video, and we'll play it right through. And whilst it's happening, I really want you to think about how could you make this work more effectively in your local context, or what other materials could you be using to tell this same story of saltwater intrusion. Graham, can you see that shared screen?
I can, Joe.
Beautiful. Now, can you also hear the music when I push play? Not yet, because it's loading, but in a second. This would be a terrible time for the internet to die. All right, folks, I'm going to try one thing. Yes, stop that. I'm going to go.
Looks like it's frozen, Joe.
So you're still here. I think my internet dropped out. Great, we've got everyone back. Okay, Graham, I can see you. I'm going to stop my video and start my video again, and hopefully, Graham, can you still see me and hear me? Brilliant. So what I think just happened, everyone, was that my internet crashed, and so I was worried for a second there that I kicked you all off the call, but I'm happy now to say that you're still here. I'll try this one more time. I think I have the video racked up. I'm going to share my screen. Okay, and now, Graham, you can see that, and can you hear? Brave new world. All right, Graham, what we're going to do, I'm going to stop sharing my screen. I'm going to get you to maybe move on to the next demonstration, if that's all right, Graham, and I'll quickly try and see if I can make this work, because for some reason, my computer is struggling to show this demonstration.
No worries, mate. Alrighty, so just while Joe is troubleshooting that, and this it's a great example of the teaching online is not easy. Okay,
I was just going to say, Graham, you're right. It isn't easy because sometimes you get gremlins. Things work once, don't work the next time, and then work again. And it looks like I might have it now. So for the third and final time, we're really building suspense. I sincerely hope this video is worthwhile now. I'm going to go and share this screen for the third and hopefully final time. Push play. Turn up the volume. And of course, we're not getting any volume, are we? So, one more thing. I think this is a little bit like learning to drive a car for the first time. And one thing that my dad said to me the first time I learned to drive a car was, if you go slow and take your time, you're not going to do too much damage. So what we're going to do now is one more time, try and do this slowly and sensibly. Share sound, push the right buttons.
Due to climate.
And we work. All right, ladies and gentlemen. Now, what I said was, I'd love you to watch this and think about your local context and what you could be using if you don't have any of the materials that you see here. And as you watch the video, throw it in the chat. Now, I promise you this is worth the wait. Let's enjoy it.
Why is it that some plants are well adapted to living in salty environments and others aren't? As sea level rise progresses due to climate change, more and more plants are being exposed to salt water. This might be through king tides, through storm surges, or via the water table. Today, we're going to look at how plants react to salt water and what sort of adaptation measures some plants use to prevent harm from exposure to salt water. For this experiment, you're going to need a fruit or vegetable with high water content. We're going to use sweet potato, but zucchini or carrot or eggplant work very well also. The other key thing that you'll need is some lip balm or chapstick. You will also need some salt, a board and a knife or a plate, and something to label your experiments with. Let's get started. Take your vegetable and cut it into 3 round pieces so you have flat surfaces. These pieces are going to represent a plant that normally requires fresh water. Label your experiment so you know where everything should go. The first piece is our control, meaning we're not going to do anything to it. This will help us see more clearly if the other two pieces have changed. The second piece will be a plant with no adaptations that is exposed to salt. This would be like a plant that grows on land being flooded by a high tide. Sprinkle a pinch of salt onto the surface of piece 2. The third piece will have an adaptation applied. We're going to use lip balm to mimic one of the ways that mangroves have adapted to live in salty environments. Mangroves live in the intertidal zone. This means that at low tide, they are surrounded by sand and air and possibly fresh water flowing from the land to the sea. Then, at high tide, they are flooded with salt water. So, mangroves have had to develop different ways of protecting themselves from salt. The red mangrove, which is common in tropical areas, creates a waxy substance called suberin that prevents salt from being absorbed through the roots and leaves. Lip balm contains some similar chemicals to suberin, so let's see if it works in the same way. Spread your lip balm thickly onto the surface of piece 3. You need to make sure the whole surface is covered. Use your fingers if that's easier. Then, like you did for piece 2, sprinkle a pinch of salt on top. Now comes the waiting part. If you're doing this experiment at home, pause this video and leave the experiment for at least half an hour. Then press play again. Look carefully at your 3 vegetable pieces. What's happened to them? Pause the video again and write down your observations. Then press play. Here's what happened to my experiment. Piece 1 looks a little bit dry, but hasn't changed shape and there's no liquid coming out of it. The surface of piece 2 is quite wet. It's all sort of glistening and it's wet to the touch all over. So this means we can see what the salt is doing. It dehydrates plants. It does this through a process called osmosis. Osmosis is when a solvent, like water, moves through a semi-permeable membrane, like a cell wall. Water is strongly attracted to the salt molecules. The water is drawn out by the salt, causing dehydration. Plants and animals are no different. If you drink too much salt water, you will also become dehydrated. Now, let's look at how well our mangrove adaptation worked. Here I can see a few drops of water starting to form, but nowhere near as much water as we saw in the second piece. This shows us that the adaptation was successful. The lip balm has created a barrier between the salt and the plant surface and successfully prevented osmosis from occurring. If you left this for a long time, eventually the lip balm would be dissolved by the salt or absorbed by the vegetable, so it's not a permanent solution. To make this adaptation work, mangroves need to continuously create suberin to protect their leaves and roots. So now we know that most plants grown on land need fresh water to survive. If they're exposed to salt, they risk dehydration and won't survive for very long. Adaptations can help to prevent this from happening, but it takes a very long time for plants and animals to adapt to changing environments, and climate change and sea level rise are happening quite quickly. How can we help plants adapt to rising sea levels? Can you think of any examples of adaptations in your community that protect plants from salt water?
Okay, so I love this experiment because it has been an opportunity for us to learn from some of the people that we work with and then try and think about, well, how can we articulate this scientific concept or this real lived challenge in a meaningful way. Now that for us is just a proof of concept. That for us was an exploration of a way that we could tell this story. I say this every single week, but I'm a Palangi, I'm a Kavalangi, I'm an Imatang. These are some of the words that I'm learning for white outsider. Now, it was been a long time since I was in the Philippines, but I actually think that they call the white foreigners Joe in the Philippines, so it fits quite well. But what I'm saying is that myself and Amira, who you saw in that video, and Dr. Graham Walker as well, we are not always the best people to tell this story to those of us that come from other parts of the world, which is where you come in, the people that we are working with now. If you think this is a useful way to tell that story, then feel free to tell the story that way. If you think there are other ways that you can articulate this phenomena to your students that is going to matter more for them, then we'd love to hear what they are. Chanel has just said that they would love to do this experiment with their students, and you can get the same materials locally as well. Oh, that's right, of course. Chanel, I'd be curious, would it work with something like taro? But you do have quite a bit of sweet potato as well in Fiji, don't you? You can type in the chat if you don't want to talk. Great. And I'd be really curious whether taro would work as well, or even better. And I know from my time, or our time as well in the Philippines, that taro is one of those crops that is extremely abundant and everyone is familiar with, and a crop that is impacted by saltwater intrusion. So it's even more connected to the challenge at hand. I'd be really curious about how that experiment worked with taro. All right, thank you. I apologise, Graham. I've taken up too much of your time, particularly with those challenges we faced at the start. But that is another way of exploring one of these phenomena. Thanks for sharing, everyone.
Wonderful. No, thank you, Joe. Thank you. And I'm going to pick up on what Joe was talking about and what Mira, who's one of our students, is talking about around sea level. So I'm going to do just a few more demonstrations that look at some of the impacts, and we're going to move on to the solutions for climate change. Now, we do have a couple of booklets that go over these activities and some more, and we'll make those available to you at a later stage. Now, I'm going to go back to my little camera here, down on the table, and have a look at another activity that you can do to look at sea level rise. And this time we've just made a really simple bit of apparatus. To make it, you just need a soft drink bottle, some tubing. Okay, we've used some rubber tubing that we got from something else. Okay, you could use a drinking straw, but we all know single-use plastics aren't doing good things for the climate either. So we've tried to recycle things here, and we've put a ruler. Now, if you don't have a ruler, you could just use a stick to hold it up. But the ruler's nice. It's got little measurements. Okay. Now, here I've drilled a hole so the tube goes right through into the water, and I put some blue food colouring in, mainly just so you can see it. And I've sealed that up with a little bit of blue tack or press stick. You could use plasticine, hot glue, whatever you've got handy. Now, the best way to use this model with students, and it's a model to show the effect of our warming atmosphere on our oceans, is to actually go and put something like this out in the sun and see what happens. And if you've got any suggestions in the chat of what might happen as it warms up in the sun, I would love to see them. So usually putting that in the sun and letting the sun heat it up and seeing the effect would be a good way to go. Now, we don't have any sunlight left here in where I am in Canberra, and we also don't have time to watch this in the sun. But so what I'm going to use is actually some hot water. Now, this comes back to when we were talking about our different models. Now, this is a nice model that shows a really important property of water, and shows us one of the ways sea level rise is happening. But it's also, it's a model. So we have to be careful what message they take. Now, I'm going to pour some water in there. And as I said, using this hot water to warm up my water inside doesn't make this model that clear. Okay, putting it in the sun would make this model a lot clearer. So just think about, whenever you're using models, really trying to do everything you can to make the model as representative of what it represents as possible, and using hot water wouldn't be the best way of doing it. But in the interest of time, I have used hot water. Now, what you can probably see here is this water level just there, very slowly creeping up. And it shows us something interesting about water, and it shows us what's happening. Or one of the reasons that sea level rise is occurring is that water gets bigger as it gets warmer. So I've put some heat into here. The water in the bottle is absorbing that heat, just like our oceans are absorbing heat from the atmosphere, and that warms up the water and it causes it to expand. Okay, it's gone up about another centimetre in the time that I'm talking. So what we see here, it is responsible for about half of sea level rise. So a lot of people, a lot of students will think it is all about will think, sorry, my camera is malfunctioning. A lot of students will have ideas that it's the ice caps melting or it's glaciers melting, and that's certainly part of the story with sea level rise. But the other part is that as the oceans absorb that heat from the atmosphere, they actually increase in volume. So nice little bit of apparatus that you can make just from common items. And again, you could turn this, you could use it as a demonstration like I just have, or you could use it as an inquiry with your students, getting them to make predictions, take measurements over time, you know, and explore it in different ways. Now, I've talked a lot, or so far I've talked about what the greenhouse effect is, where the gases that are driving it come from, and some of the impacts. Now we're going to finish this story with a really, really important part, and that's to show the positive things and the solutions, okay? I think a lot of the time you see people thinking, oh, we have to change, you know, this is a terrible thing. I actually think a future where we've made all these climate adaptation and mitigations would be a lot better. Cars not making pollution. There's a lot of positive things. And when I'm talking to people, particularly young people, about climate, I like to try and highlight that there's lots of positive things, okay? There's lots of negative things. We can't gloss over them. There's lots of positive things about how we're changing. And I just want to ask people that are on the Zoom call, what are some of the things that we can do? I mean, we've talked about how bad fossil fuels are. What can we do? What can we do instead? What kind of ways are you adapting locally, and what do you think we need to do as a global community? What kind of changes do we need to make? Any comments in the chat? One of the things that I get quite excited about, because this is some adaptation and mitigation that I can do at my own house, is using solar panels. And I know throughout the Indo-Pacific, lots of solar being used. It's great for small scale local electricity, and we can scale it up into big approaches. What any other ways that we can make energy that are jumping into people's minds? How can we make all this energy that we need without creating these emissions?
I know in some spaces, Graham, in Fiji, actually, we work, one of our great collaborators in Fiji lives on the island of Kandavu, which is where they make a whole bunch of things, one of which is kava, which Kandavu is famous for. And I was talking to our colleague over there, and he was telling us the vast majority of the energy that they generate on that island is from diesel generators. But they're a small island surrounded by waves and quite strong tidal currents. And so one of his suggestions was, well, we could always move more and more towards tidal and wind powered generators, which we're seeing more and more around the world. And that was one that really stuck out for me.
Yeah, wonderful. All right, I'm going to put, I've got solar and I've got wind on my list. We're going to talk about both of those things. And the other one I wanted to talk about, and I'm glad you brought up Fiji, because they're using this technology in Fiji as they're using it in tropical Australia, is around the kind of fuels we use. So things like solar can be really good for, say, household applications, and we can scale them up and use them for electricity in the grid. But for more portable fuels, there are more challenges. Okay, we can use things like batteries. We'll talk about that in a second. But I wanted to talk about a fuel that we can make using plants. So in here, I've got some methylated spirits, or ethanol. Okay, it's a biofuel. It's a fuel that we can make through fermentation, and we can use crops like sugarcane. And we can also use waste materials and biomass as a source of biofuels. So with our biofuels, and I've put some just in a little spray bottle, you'll see why in a second, they still create carbon dioxide emissions as they burn, fuels like ethanol, but as we produce them, because they're produced from plants, we take carbon dioxide out of the atmosphere. So in an ideal system, we've kind of got a closed loop there where the fuel creates carbon dioxide, but the production of the fuel takes in carbon dioxide. So not a perfect solution, but definitely better than using fossil fuels like petrol and diesel to produce electricity. Now, I'm going to show you a nice little demonstration, again, one that I'd recommend doing as a demonstration rather than getting your students to do, again, because of the safety issues. But if you have upper secondary students, you might want to consider using this with them. So what I've got here is an aluminium can, and again, I've put a little hole in it, and I've got just a nice, just a drinking cup. I'm going to put a little bit of my biofuel, and I'm just using ethanol or methylated spirits into my can. Spray a little bit in. Okay, and you don't want too much, okay? If you're using a spray bottle, or if you're just pouring some out of a bottle, just make sure that you haven't got any residual liquid in there. We're going to pop that on here, and we're going to see this energy from our biofuels. So once again, it's a fuel that does produce carbon dioxide, but it also traps carbon dioxide as we make it. So let's just bring our lighter close to the hole. Ooh. And off we go. Okay, so that fossil fuel, if you can still see a little bit of it burning there, just really take care. Okay, it is still on fire now, and I've just blown it out, and we've produced some carbon dioxide, but in the production of this fuel, we've trapped some carbon dioxide. So nice little activity. We can show how biofuels work. But ultimately, we need to move to fuels or ways of making energy that are completely emissions free. Okay, and we need to get there quite quickly. That's what all the science is telling us, and this is why sources like solar and like wind, and we heard an example from Joe using tidal energy or hydroelectricity, they're all really, really important things for us to embrace a lot quicker. Now, one of the lovely things you can do if you can get your hands on some little solar panels is an activity we found that students really enjoy. I've got a couple of solar panels here. Now, if you can get hold of little solar panels locally, they can work really well. The other thing you can try is finding a solar powered device. So it might be a little garden light or anything else, and actually getting the solar panel out of it, okay? The other thing I've got here is just an old, or it's a kit for a toy. Now, this toy used to run on batteries, and you can see what I've done is to replace the batteries with this solar panel, okay? And it's a really good way of showing the students what the solar panel does. Turns light energy into electricity, and you could attach this to any car, okay? Sorry, any kind of toy that runs on batteries. Some of them don't work that well on solar power, but great exploration from your students. And it shows we can really do this stuff. We can repurpose and reuse a lot of materials. Now, I haven't got the sun in here, but I do have this bright light, and we're going to use that to replace the sun. If you are doing explorations with solar power, I'd really recommend getting out and using the sun because it's so much more powerful. You think this light is pretty bright. It's nothing compared to the huge amounts of energy that are falling on the planet. So lots and lots of resource, lots of opportunity, and solar power is one of the ones that I get quite excited about. Now you can see my little car here. If I pop my light on, suddenly we start making electricity, and you could adapt kind of pretty much any toy. All right. The only consideration that you want to think about, this toy usually runs on two AA batteries, so a 3-volt source. So I've found panels that work well for that. Okay. And my panels were only 1.5 volts. So I've had to think about how I wire them together. So there's some great kind of problem solving and construction and making activities in this kind of thing. You will find if you are in a position to purchase resources, you'll find lots of kind of kits and things online. This is a slightly fancier one that we've got here. And if we've got any people tuning in from Kiribati or Tuvalu or Fiji or Samoa, we're actually posting some of these kits across to those countries, so they're available to you. This works on the same kind of idea. We've got our solar panels, and they're turning light energy into electricity and driving a motor. Now, the cool thing this one has as well is a little capacitor, which acts like a battery. And it shows us a really important thing, that with renewable energy, so particularly solar or wind, tidal or wave energy, they're not always going to be producing. So we call this intermittency, and it's one of the challenges of replacing our old fossil fuels, which works best if we just burn, with these new cleaner technologies like solar, which are great at producing electricity on a sunny day, but maybe not so much at nighttime, or not at all at nighttime. So being able to store the energy is really important. That's what a capacitor does. That's what these big batteries do. And at the end of the workshop, I'm going to show you a way that you can do it using really, really simple everyday items. So solar can be a great renewable energy source to explore in the classroom. If you can't get hold of solar panels, the other one I'd really recommend is rather than using the sun's light, which is a solar panel, turns light energy into electrical energy, we can look at the sun's heat. I've got something down here. Okay, lovely. That is designed to collect the sun's heat. Now, this is something that, again, you can make just with really simple items. And what I've got here, I've got an old box out of the rubbish bin outside. A kind of flat wide box works really well. A pizza box works really well, but any kind of box will work. And I've done a few things. You'll notice I've cut a hole out here, then I've made a lid, and that lid is covered with foil. Okay, and that foil is going to reflect the sun's heat. So imagine the sun's heat coming down here, bounces off our foil and into a solar oven. You might be looking at going, what is this thing? This is actually a solar oven, okay? And it collects the sun's heat. The heat reflects off there, goes into here, and you see I've put some Glad wrap. You can use whatever kind of clear plastic you like to actually trap the heat in there. And I've lined the hole inside with foil as well to really trap the heat. The other important thing you'll need is to make sure your box has a little spot that you can open, like you can see at the front here. So you can actually put some food inside. Now, you don't want to use this to cook anything that requires thorough cooking, okay? So don't use it for sausages or chicken or anything like that. But we found it works really nicely, just like with a biscuit with a bit of chocolate on it, and you can kind of melt the chocolate just to show that idea. Now, the last thing I'll point out is we've got a black square in the middle. And if anyone would like to take a guess at why it's important to have that black square there, I would love to see any comments in the chat. And if you make one of these, we'd love to hear how it works. But often those explorations in renewable energy using the sun's heat can be a lot more accessible if you can't get hold of solar panels. Lovely. So I've got just a little bit of time left, and I wanted to show one more little activity using wind energy. And again, we can do this with really simple items. We can get to make a wind turbine, we can just use really simple things, okay? I've got a design that's just based on an old cup that I've cut up to make our rotors. Now, you can make these little wind turbines and explore renewable energy. If you do have a little electric motor, again, you can get this out of maybe an old toy, an old car or something, or if you can get hold of a little motor, we can actually make a real live working wind turbine. And to do that, I've attached my wind turbine onto a little ammeter. You could have any kind of multimeter or whatever else will work. We could put it out in the wind and we could record it, but I'm going to make some wind just by blowing. And okay, and hopefully, because I'm well out of breath and about to faint, we can actually see that we can produce electricity using our generator, which turns that kinetic energy, moving energy of the wind into electrical energy using our generator, and we can measure that there. So really accessible things that we can do to explore renewable energy. And finally, I just want to finish on one last activity that goes back to this idea of how we can store our renewable energy. And this is some science that I get quite excited about. And talking about a fuel called hydrogen, which we can actually make from sunlight. Now, there's different ways of making hydrogen in the classroom. Some of them are very dangerous, so be careful what you read online. I'm going to show you one that is really good and really accessible for students. You just need a couple of pencils and some water. In this water, I've put a little bit of magnesium sulfate, or commonly sold as Epsom salts. You put it in the bath for sore muscles. If you can't get hold of Epsom salts, you could use table salt, but just take care. When using table salt, the reaction will produce a tiny amount of chlorine gas, so make sure you do it in a well-ventilated area. With our Epsom salts, we don't. So what we've got is a really simple apparatus to do electrolysis with. And the pencils, we need to actually use the graphite or the carbon in the middle as our electrodes. This is where the electricity is going to flow. To get the electricity into, I've just put a little battery holder there, and you can see I've shaved off the wood and put the wires on there and put some tape to secure it. Now, there's lots of different ways you can stick the wires onto the pencil. You might have some of the alligator clips and things like that. The important thing is you've got a good connection. So we're going to have a good electrical circuit. Now, what we're going to do is actually use the electricity in this battery to create a chemical reaction. Okay. And we're going to create a gas that has huge potential for tackling climate change, hydrogen. It's a very common gas. And but it's one that we can burn to create energy without creating gases like carbon dioxide. And we can actually make it from something as simple as water. Now, water is H2O, and we're going to use the electricity in here to drive a reaction. Now, this is quite hard to see on the webcam. It highlights one of the challenges of these kind of remote learning, but I'm going to do my best to show you what is happening in that cup. Now, on that pencil, you might be able to see some little bubbles starting to form. Would anyone like to take a guess at what those bubbles might be? Any guesses at all? You see a couple of little bubbles come out. Hey, someone has said hydrogen. Thank you. Thank you. So we're producing hydrogen from the water, and the electricity is driving a chemical reaction that we don't usually see and breaking the H2O into hydrogen and oxygen. Okay? And we actually see it happening. Now, you might think, what does this have to do with climate change? And it's a really good question with a really exciting answer. If we, rather than using a battery, if we instead use a solar panel, then we can produce hydrogen from sunlight. And for fuel, or where we need fuels that are mobile, so we need to power a ship and we don't want to use diesel, using fuels like hydrogen can be a really good solution. It also gives us a way to export renewable energy and move it around the world. Okay, so at the moment we dig up lots of fossil fuels, we transport them around the world. What we can do with these technologies is move on to actually transporting renewable fuels around the world. And it's a much, much more exciting thing. Great science, but also great solutions. So look, on that note, I'm going to finish these demonstrations, but I just wanted to highlight the kind of narrative where we started off with the impacts and what's actually going on with climate change. But we always are careful to reinforce that there are solutions, there are things that we can do, and we really want to give our students as much empowerment and to feel that they can make a difference, because climate change is a global problem, but if everyone does their little bit, then it's going to make a huge difference. And whether that's in our own behaviour or whether that is pressuring our politicians and our decision makers to make better decisions on our behalf. So lots of different ways that we can empower our young people. So I'll finish there, but if there's any questions or anything like that, I realise I've gone almost to time, so I'll throw back to you, Joe. Thank you, everyone.
Thank you very much, Graham. I'd like everyone to join me with a real or a virtual or an imagined clap. And congratulations to Dr. Walker for taking us through that. Yeah, really, really informative. Every time I see it, I learn something new, and something new comes out of the conversation. So thank you so much. A few things that I do want to quickly touch on. I've thrown into the chat the link to the survey that you can complete, provide feedback, and then get your certificate for this session. I've also included the link to the closed group for anyone that wants to jump in there and be part of these continued conversations. As I say, this is our very last workshop in this series. Speaking personally, it's been an absolute pleasure to interact with all of you, and I would love to keep doing that. So please do join that closed group. The final thing I would say, there is 2 more weeks left to enter the micro grant competition that we are running, where as a teacher, an educator, or a communicator, all you have to do is share some version of a lesson plan and then show us implementing that lesson, show us you implementing that lesson plan, and you are in the running to win up to 150 Australian dollars in micro grants. We know it is a small contribution, but we hope it is something that will aid you going on this journey of communicating remotely, communicating in general, communicating STEM, and in this instance, communicating climate change specifically. And Chanel, before I go, I definitely want to see that experiment done with tarot. And why not enter it into the competition? If you're going to do it anyway, it is prime and is a perfect example of tailoring something that you have seen to suit your context better. All right, everyone. That is all from me. Graham, is that all from you?
No, just to say that we will make some links to resource booklets for the activities you've seen today, along with a whole lot more available. And we'll circulate those links to everyone that's come along to the sessions.
Our regular viewers, our regular joiners will know that generally within the next 12 hours, they'll get an email from me with several thousand links. And in that email, you'll also get links to those documents as well. So I look forward to being in touch. That's all from us here in Australia. We hope you're safe and well wherever you are across Asia and the Pacific. And we hope to interact with you again soon. Bye-bye.